Okay, this is the final lesson that actually has new material that will be on the unit test. Vocabulary review. An exponent tells you how many times a number or base is used as a, who has the answer for that? Rudy? I'm sorry. Glorbell? No guess. Does anybody have a guess? Nice. Thank you. Could you say it a little louder?
Factor?
Yes. Factor is correct. An exponent tells you how many times a number or base is used as a factor. Okay. Who has the answer to number 2? Let's see. Oren, what's your answer? What is it?
6.
Number 2, you think is 6? How'd you come up with 6? Just curious. Did you think the exponent was a 2? Okay, it's actually a 3. And exponents, you are multiplying, but you're not multiplying the base to the exponent. The exponent means what? Can somebody remind Oren, what does the exponent mean? Go ahead, Logan. Okay, so Oren, if you're looking at that and you thought it was 3 to the second power, that means you multiply 3 to itself twice, so 3 times 3. So in that case, it wouldn't be 6, it would be 9. Does that make sense? So here, Oren, can you fix it? What would 3 to the third power be then? Not 12, you're adding, sounds like you added. Glorabelle, can you help him out? 27. So Glorabelle, walk me through what you did to get 27.
First, I wrote it out.
Uh-huh.
Times 3 times 3.
Okay.
And then I multiplied the 2 3s. And I got me 9. And 9 times 3 is 27.
Nice. So you got 27. Good. So number 2 is 27. And can somebody share with the class what 4 to the second power is? Caleb, all the way in the back.
It's
16. Right. How'd you come up with that?
I multiplied 4 by 4.
Very good. So here's the answer. Here's number 2. Oren, do you see the answer to number 2? So 3 to the third power is 3 times 3 times 3. These two 3s multiplied together give me 9. Then I got a 3 left over. 9 times 3 is 27. And Caleb's correct. 4 to the second power is 4 times 4. Okay, I've repeated multiplication of 4 twice. 4 times 4, 16. Okay. What would 3 to the first power be? Class, what's 3 to the first power?
3.
It's just 3. What's 4 to the first power? 4. So if I don't have an exponent with the number, can I put an exponent with it? Right, I can always put a 1 with it. Does that make sense? Okay, that's going to come up later. I just want to get you guys ready for that. Okay, they don't really talk about it yet, but I want you guys to be prepared for that as we start seeing more and more algebra topics. Okay, who's got number 4? That was kind of a tough one, but if you guys remembered my shortcut, you might be okay. Fatima? Nice. How'd you come up with 100,000?
So first, I lined them up and multiplied 10 times 10 was 100.
Okay.
And then since it's multiplied by 10, I just add a 0 by rounding it off.
Okay, so I worked it out, but there is a shortcut here. 10 to the 5th power, if I write it out, it's 10 multiplied by itself 5 times. You guys see that? And then 10 times 10, the first pair of 10s that I'm multiplying is 100. But then I have 3 left over. And then I multiply 100 times 10, that gives me 1,000. Then I have 2 10s left over to multiply. 1,000 times 10 gives me 10,000. Then I got one more 10 left over. And 10,000 times 10 gives me 100,000. Are we good? Questions? Do I have some questions? Yes. Timothy, you have a question?
I actually gone a different way.
Uh-huh.
I just added a 0.
Okay. If you add zeros from the exponent, that 5 tells you how many zeros to have. How many zeros do I have?
6.
I need 5. So it sounds to me like you have 6, right? So do you see how to fix it? So the exponent is going to tell you how many zeros to have. Okay, and think about that. What's 10 to the first power, right? Is the same as 10. How many zeros are 10 in 10 to the first power? 1, and the exponent's 1. Do you understand? See how that works with what we just talked about? Okay, who's got 2 to the, question in the back.
So I got 1 billion. Well, not 1 billion. No, 1 million. What? Because
How many zeros are in 1 million?
6.
Okay, does that match my exponent?
Because I added the
Shh, stop, right there. Get this right mentally because we're going to use this today. For powers of 10, the exponent tells you how many zeros to have. You understand? So how many zeros do you have for a million?
6.
What's your exponent here that we started out with? Do you see where you're off? Because this is important to today. That's why I'm trying to emphasize this right now. Okay? So I got 10. It's a power of 10. The base is 10. The exponent is 5. My answer is I have 5 zeros. You understand? Okay. Get that right now. It's going to make your life a lot easier for this lesson. Okay? And that's kind of review. I mentioned that in the past, but today it's going to be even more critical that we know that because that's going to time with what we're doing for the day. Yes, Abu. Okay, I want to hear somebody different who's got number 5. Joseph. 16. Did you guys get 16? Yes. Okay, let's walk through that one. Here's the solution right here. 2 to the 4th power. When I write that out, it's 2 times 2 times 2 times 2. The first 2 factors I multiply 2 times 2, I get 4, but then I have 2 left over. Do you guys see that? Okay, now I got to go ahead and take care of 4 times 2. That gives me 8, but now I have 1 2 left over. And then my last multiplication of 2 will be 8 times 2 gives me 16. Are we good? Any questions about that? Yes, Logan.
Question, but I don't think you can always do this, but I just reversed it because I wasn't sure if I got the same amount.
Mm-hmm.
Because I didn't write it out. So I just reversed it and did 4 times 4.
And that's actually correct. So she had another strategy. I'm showing this one, but now remember multiplication, it's, I could change the order. Do you guys remember what property that is? Oh, I'm sorry. If I misunderstood you, I apologize. You can change the order. Do you guys remember what property of multiplication that is?
Yeah. Commutative.
Right, commutative. So look, if we're using this, look, 2 times 2 is what?
4.
Then I take these 2s. 2 times 2 is what?
4.
Right, and then 4 times 4 is? Okay. Are we good? So there's more than one way. I could have multiplied these. You understand? So I wanted to show one way, but you guys can be creative on what makes sense for you. Okay? All right. Any other questions about the warm-up? Here's today's lesson. And I know you're going to be covering this with Miss P. So you're going to be tested on it twice. Math class and with Miss P. Because I know this is a standard covered in science class too. No, don't get panicked. You're going to. I don't know when she's covering it. I know it's about this time, maybe give or take a few weeks. I know that she does cover this also. All right. For the sake of the video, I'm going to go ahead and read this. What you'll learn: to write numbers in both scientific notation and standard form. New vocabulary. Scientific notation. Why learn this? Some numbers are so large they are difficult to write. You can use scientific notation to express large numbers, such as distances and speed in space. Scientists use scientific notation to calculate with large numbers. You previously learned about exponents. When the base is 10, the exponent tells you the number of zeros the number will have in standard form. So in the warm-up, standard form would be no exponents. Do you guys understand? Are we good? And some of you guys were, I think, confused with the question from the quiz that I just entered. It said, rewrite this exponent in standard form, right? That just means they wanted you to write it out. What is it equal to without the exponent? Okay, question.
Didn't the second
Are you talking about the quiz? Yeah. For some people, yes. For some people, no. So I just wanted to bring it up. Okay, so moving right along. Take a look at this table down here. Powers of 10. So here you have exponent form. Here they're telling you how many zeros are associated with that exponent of a base 10. And then standard form is just what's that number without the exponent. Do you guys understand? So look in the first column. What do we see there? Do you guys remember what I said? You can always write any number with an exponent of what? 1. If there's no exponent, I could always put an exponent there. I could put 1 there, right? And 10 to the first power, how many zeros do we have with 10 to the first power? I have 1 0. And in standard form, it's just 10. Now, what about 10 to the second power? How many zeros does it say in our chart we have for 10 to the second power?
2.
Okay, I have 2 zeros. 10 to the second power is 10 times 10. And 10 times 10, as we know, is what? 100. And we see there are 2 zeros with 100. Okay, 10 to the third power. The exponent is 3. 10 to the third power is 1,000. How many zeros in the number 1,000? 3. Okay, do I need to go on, or do you guys see what's up with this table? We're good? If not, I'll keep explaining the rest of the columns, but we're good? We can move on? Okay, now, how are we going to use that? Well, first of all, let me do a really quick review. Do you guys remember that number, Gogol? Remember that number? Do you guys remember that number? It's a really, really long number. A Gogol. A Google. Do you guys remember that from that lesson where we first started talking about exponents?
No.
How many zeros were in a Google?
Like 50.
It was 100, right? It was 1 with 100 zeros, right? And you saw how big that number is. We don't want to write big numbers sometimes. Sometimes we just want to write it in a different notation that represents the large number. And a Google we represented by writing what? With an exponent. 10 to what? 10 to the 100th power, right? Okay, so we already see the advantage earlier this year when we first talked about exponents. A Google, that's a big number. We don't want to write that number all the way out. You use exponents to help you write it out. Well, scientific notation, sometimes you're dealing with really, really large numbers, and sometimes you're dealing with really, really, really small numbers. Okay? Well, how do we deal with that? That's why somewhere along the line, somebody came up with this scientific notation. Somebody got tired of writing these big, humongous numbers. They said, how do we write this so that everybody understands what we're dealing with without writing out all those zeros? Do you guys understand? Well, that's what we're going to talk about now, scientific notation. And you'll learn more about this in your science class with Ms. P. So, when you multiply a factor by a power of 10, you could find the product by moving the decimal point in the factor to the right. So when we multiply, we're going to move it to the right. Are we making the number bigger or smaller if we move the decimal to the right? Bigger, right? Okay, the exponent tells you how many places to move the decimal point. When you divide by a power of 10, you move the point to the left. So when we're dividing and we move the decimal to the left, if we're dividing by a power of 10, okay, if we're moving the decimal left, is the number getting bigger or smaller? It's getting smaller. So let's think about this. So now we have another chart. And on this chart, the chart's titled Multiplying and Dividing by Powers of 10. Okay, so let's look up here. In standard form, if I multiply 3 5/10 by 100, would you guys mind really quickly multiplying 3 5/10 by 100? I'm only going to ask you to do this one, okay? And then hopefully we can talk about the pattern here. So really quickly, I know every one of you can do this. Multiply 3 5/10 by 100. Can you guys do that really quickly? Take out your paper. Let's multiply it out. Do it the long way. Do it the long way. Multiply it out. Remember how we multiply decimals? Okay. Multiply it out. At the end, you worry about the decimals. For those of you guys forgot, or those of you guys that never got it. Okay. Some of you guys, there's a handful of you guys that still don't have multiplying decimals out. I need you to do. I'm going to call on people that actually tried to do this. without raising their hand before they even tried? Because I didn't want you to mentally do it. I'm going to talk about the shortcut in a moment. I want you to actually work this out. I'm looking at like 3 people who threw their hands right up. They didn't even have paper out, didn't even try it. Most of you did try. That's good. So who worked this out on a piece of paper? And can recall for the class, what do we do when we multiply numbers that have decimals? Can somebody refresh the class's memory? How do we do that? When I multiply 2 numbers and they have decimals, what is the process? All the way in the back. Miles, how do I multiply 2 numbers where they have decimals? What's the first step?
Take the decimal out.
Well, you don't really take the decimal out. Let's go ahead and multiply this. You don't even have to line up the decimals, do you? First step, we have to do what? We just multiply them. The last step for multiplication of numbers with decimals is to worry about the decimals. You're thinking of adding and subtracting decimals. When you add and subtract decimals, then you have to line up the decimals. When you're multiplying decimals, you don't have to worry about the decimals until the last step. Okay, so here's my numbers that I asked you guys to multiply out. 5 times 0 is what? 0. 5 times 0 again is what? 0. 5 times 1? 5. Before I take care of that 3, what do I have to do? I got to put a place value here, a placeholder. Okay, now let's continue. 3 times 0? 3 times 0 again? And then 3 times 1? Okay. Now we're just going to go ahead and take the sum of these 2. And the sum of these 2, well, add up my zeros. 0. 5 and 0 is 5. 3, bring that down. Now the last step is, where are we going to put my decimal? Okay. Well, 100, there's no decimal. We can always put a decimal when there's no decimal. Where's the decimal going to go? Does it go over here? No. On the left-hand side of 100? No, I just made it smaller. It goes right here at the end. How many decimal places are there with 100? None. There's 0 places. How many decimal places are there with 3.5? It goes in 1 place, right? So 1 plus 0, 1 place. Now I'm going to take this 1 place, and I'm going to go in, how many places? 1 place. So here's my answer once I've done all this. What's my answer? 350. So let's ask ourselves, if we started out with 3 and 5/10, and when I multiplied by 100, my answer was 350. What happened to my decimal? That's what we should be asking ourselves right now. What's happening to my decimal? My answer equals what? 350, right? Look at where my decimal here is with what my factor was, 3 and 5/10. It was right behind the 3, right? Now with my answer, 350, where did it end up? How far from the 3? 2 places which way? To the right. Okay, because I was multiplying, right? So 2 places to the right when I multiply. So if I divided by 100, which way would my decimal go? 2 places to the left. Okay, so when we multiply 3 and 5/10 by 100, we get 350. If we divided 3 and 5/10 by 100, do you see where my decimal ends up? It moves over 2 places to the left. Do you guys understand? Okay, so continue on. 3 and 5/10 divided by 10, it's going to move how many places in which direction? 1 place, which way? To the left, because we're dividing. So look, it goes from here, and then it moves over, and then I got 3500ths. You guys understand? Okay, here, this is the one we just worked out. Now, what about when we multiply by just 10 to the first power? I'm moving it how many places in which direction? I'm moving it how many places? One place in which direction? To the right. So 3 and 5/10, move it to the right one place, that becomes 35. Okay? This is what we just did. We saw 350. We moved it to the right 2 places. And then what about 3 to 5/10 multiplied by 1,000? How many places in which direction?
3 places.
3 places to the what?
To the right.
To the right. So you see, if I move between the 3 and 5 over 3 places, I get 3,500. Okay. Now, let's go revisit the warm-up and what I was talking about and trying to emphasize with Christian. Christian, do you see now why I was trying to really stress that point? Okay. So you don't have to go through all of this down here to figure out what the product or the quotient is of powers of 10. You're going to use these tricks. You guys understand? Now, when you show your homework, your work, I want to see that you counted decimal places over. I want you to write the problem out. I want you to show me that you understand what's going on. Okay, so whenever we have a lesson, whatever that lesson's on, I want you to write out what your steps are as it relates to that lesson. Do you guys understand? Now, later on, I'm not too pressed with that, but whatever the lesson we're working on, I need you to show me the steps from that skill, from that particular lesson. So in this lesson, when you show your work, I need you to show me how you're moving your decimals. Okay, I have a handful of questions. Yes. Sign out sheet. Okay, scientific notation is a shorter way to write numbers using powers of 10. Here's the key concept. Okay, a number in scientific notation is written as a product of 2 factors. One of my factors is greater than or equal to 1 and less than 10. Got that? I'm trying to get you guys to understand what the key concept's saying. Here's an example. The other, a power of 10. This is the other factor. So these 2 numbers, the first is always greater than 1 but less than 10. Do you guys understand? That number right there is always greater than 1 but less than 10. Okay? This number is some power of 10. Okay? So you see we have this really, really big number. Does anybody know what that number is? So this would be the hundreds. This would be the thousands. This would be the what? Millions. Billions. Trillions. Okay? Fatima, could you say it? Please don't talk out of turn.
7,500,000,000,000.
Okay. So we don't need to express all these zeros. We can show it here in scientific notation. Are we good? Questions about math? Any questions about the material so far? Tiana.
So if it's something like that, that means we have to put in the exponent.
So the whole purpose of this lesson is to make it into, take a standard form, number in standard form, write it into scientific notation, and then also go backwards from scientific notation to standard form. Okay? So that's to summarize what you're doing today, that's what you're doing. You understand? Okay. Moving right along. The moon orbits Earth at a distance of 384,000 kilometers. Write this number in scientific notation. Try. Everybody should be trying right now. Okay, I'm going to pick somebody I haven't called on yet. You got an answer for me? Try. I need you to try. I'm calling on you because I'm looking at you and I don't see you really trying. Don't make the unit test your first attempt to try this because it's not going to go well. I can't help you during a test. That shouldn't be the time that you're trying. Now is the time to try. Now is when I can help you out. If you're going to wait till a quiz or the day of a test to try, that's not going to go out. That's not going to turn out so well. So go ahead, try it out. We need to make our first number between 1 and 10. Let's make our first number between 1 and 10. It's got to come from that number, Uche. And then we make an adjustment. So 3, okay, 3. But I need to show the rest of the number. 3, what? It's got to be between 1 and 10. 3 and what? I got to show all these numbers. So look, the digits I have here, okay, there we go. The rest of the zeros we're going to take care of with our power of 10. Do you understand? Now, I need to put a decimal here somewhere so I can make this number between 1 and 10. Where would my decimal be to make this number between 1 and 10? Nice. So that's step number 1. You guys follow me? Step number 1, take your number, the digits that aren't 0, make it a number between 1 and 10. Do you see how we did that? Now how do we make our adjustments? So this is what I did here with those set of digits right there. Okay, any questions about what I just did? Is that a question? No. Okay. So now I got to deal with making it something that's equal. So if I'm starting out with this number, I need to make it equal to this in standard notation or scientific notation. I need to make standard form equivalent to what I'm about to write in scientific notation. So remember in the key concept, my first number has to be between, it has to be greater than 1, less than 10, right? And then my second factor has got to be a power of 10, right? So factor means I'm multiplying by 10, and I got to figure something out. Look at where my decimal is right here. You see that? It's between the 3 and the 8, like Uche just said. Okay? So the number I start out with, did it have a decimal? Was there a decimal there? No. But we know where the decimal is, right? We can always put a decimal into a number. The decimal is going to be right here. And in order to move the decimal from here to between the 3 and the 8, how many places does it have to move? I'm here in 5. Let's count. 1, 2, 3, 4, and 5. So to move it there, it's got to go 5 places, right? So in order to make this equal, my exponent has got to be 5. All right. You're to do that was my example. You're to do, and I'm going to come around and look at your paper. You're to do this one, the next one. Read it, answer the question. Okay, I still see a few people writing. When you're done, if you can put your pencils down when you're finished. Timothy, do you have an answer for me?
1 and 69,000.
Okay, so you took You said 1 and 69, not thousands. What would that be if I'm just taking a look at the numbers? 69 hundredths. And then what's the rest of it? Times 10. And you're saying to the 9th power? 10 to the what power? So we start out with 169 thousandths. And you're saying 10 to the what power, excuse me? Power of 5. Do you guys agree with them? Is it to the power of 5? So the number in standard form, here's the decimal. If we move it 1, 2, 3, 4, 5 places, okay, that means my exponent is 10 to the 5th power. Okay, questions about what we've seen so far? Okay, I got a number of questions. I'm going to start over here. Logan.
Okay, so when I did it, I just put the decimal in the place and just like added the number, like placed like the zeros to the numbers after the decimal.
Mm-hmm.
Can you do that?
You just wrote that number out, put the dot there. Is that what you said?
Like added the 69 digits to the zero.
Okay, so whatever you're putting here for your first factor has to be between 1 and less than 10, right? Okay, so is that what you started out with? All the extra zeros, you're showing that with the power of 10. Do you understand? So these extra zeros, we're not going to write all these zeros because these numbers can be very large. So that's why we're writing this part right here.
And I'm saying, like, can you just add the zeros to the 69?
Right. Okay, I hear what you're saying. So we have 3 zeros, and because we're moving it between the 1 and the 6, you have 2 numbers there. So the 3 plus the 2 numbers, that's 5. Yes. Okay. So I'm just trying to visually show you guys what's happening. So yours works just right. What you're thinking is correct. Okay. Other questions? Abu.
Can't you put the decimal somewhere else besides the no?
This number has to be between what 2 numbers? Do you remember from the key concept?
1 through 10.
Okay. So if you put it anywhere else, it's not going to be between those 2 numbers. Okay? Any questions? Did we answer most of the questions? I saw a lot of hands. I don't see as many hands up now. Okay. So by answering these 2 questions, it looks like I've answered everybody else's questions. Okay. Now let's move right along. Now, we need to go backwards. So we went from standard form to scientific notation. Now we need to go from scientific notation to standard form. So let's see if you guys can figure this out without me explaining the example to you. Okay, I still see a few people writing. Still like maybe 1 or 2 students that weren't really trying. They're just kind of sitting there. Most of you guys are doing what you're supposed to do, though. Okay, when you're done, if you could put your pencils down so I know who's finished. You know who I haven't heard from today that I'd like to hear from? Terrell. What's up? Can you tell me a strategy? Do you have an idea of how to go about this? Okay, since the exponent's 8, then what? You put 8 zeros? Is he right that you're going to add 8 zeros? How can he fix his thinking? So he's on the right track. Terrell, you're correct. You're going to look at that exponent, and you're going to add some zeros. But the 8 doesn't tell you how many zeros to add. The 8 tells you something else. Caleb, can you help him fix the steps?
Instead of adding zeros, you use move the decimal.
Okay, so 8 is not telling you how many zeros to add. 8 is telling me how many places to move my decimal. So very good. So Caleb, what was your answer? Can you tell me that number?
I got 230 million.
So let me start out by writing this out. And I'm going to add some zeros. Let's see how many zeros I need to add. And I might need to add or erase some, but we'll go ahead and start out with adding 8, like Terrell said. Okay? But now we're going to take this and we're going to move it 8 places. So this exponent 8, move it 8 places. So from here, I'm starting really small, but this number is a large number, so I got to make this number bigger, so I got to move it to the right. So 1, 2, 3, 4, 5, 6, 7, 8. Did I put 8? So I only put 7, so actually I'm okay, because here's my decimal right here. Now let's put some commas in to help us say this number. I'm going to rewrite this number. Okay, let's throw some commas in. What is that number? Are we good? Okay, now that we've worked out one together, can I get you guys to do this next one? You know who I'd like to hear from now? Saki. Right, so what number am I starting out with? Okay, that's what I'm starting out with. You're saying I'm going to move the decimal 5 times, so let's go. How many zeros am I going to add if I'm moving it 5 places? 4. So 1, 2, 3, 4. This number right here says I got to move it 5 places. So 1, 2, 3, 4, and 5. So if I rewrite that number, throw some commas in, what's that number, Saki? 640,000. Did everybody get that? Any questions about this? No. Okay. We're to the end of the lesson. Oh, Boo, what's your question?
Do we have to do like this on our homework, or?
Yeah, I need you to show your work just like I'm showing here. Okay, move along. Describe how to write a number in scientific notation. Who can describe how to write a number in scientific notation? Armani, can you give it a shot? It's okay. This is the learning part. I'm not quizzing you. We're just trying to see if we remembered what we just covered. Go ahead.
When the 10 has an exponent, like 5, you're going to have to move the decimal 5 times.
Okay. Remember there's 2 factors, right? What's the first factor of a scientific notation supposed to be? It's supposed to be between 2 numbers. What are they supposed to be? 1 and what's the other number? It has to be more than 1, but less than what? 10. And then the other factor is what? The other factor, let's go back. So scientific notation, right? This is the first factor, like the quick check we had, 6 and 4/10. That was the first factor. It's between 1 and 10, right? And then the other factor is going to be what? A 10, base 10 with an exponent, right? So let's look what the book gives us for an answer. There it is. It is written as the product of 2 factors, one greater than or equal to 1 and less than 10, and the other is a power of 10. Are we good? Okay, the next thing. Take a look at this. Is this number written in scientific notation? I need you to give me yes or no and why or why not. Somebody I haven't heard from yet. You know who I haven't heard from yet? That I'd love to hear from is Tayana. Yeah. Is this number scientific notation?
No.
Why not?
You have to put a decimal near the, you have to, wait. Yeah, you have to put the decimal in between, 1 and 0.
Right. So if I wanted to make this into scientific notation, you're absolutely correct. I would need to write it this way, but now I got to fix the exponent of 10. So if I move this over 2 places, that means I have to do what? I got to change my exponent not from a 4. How many places did I just move it? 2. So I got to add to that 4 and make it a what? 6. So that's awesome. That's awesome. You're thinking on another level. I just wanted you to answer the question if this was an exponent, if this was scientific notation, and all you had to do was say no. Because that number is not between 1 and 10, right? But you went a step further and said, no, I want to fix it. Good. That's really good. Now, how about this? Fill in the blank. Can somebody tell me what the exponent of that number is going to be? Somebody? I haven't heard from, who I haven't heard from today? Jonathan. I haven't heard from Jonathan. Shh. Jonathan, what's my exponent going to be? Well, don't look at this. We're trying to make this equal to this. So the decimal is here, right, at the end. So if the decimal is at the end, how many places would I need to move it so it's between the 1 and 7? 2, 1, 2. Does that 3? So we need to move it 3. So 1, 2, and then 3. So that means 10 to the 3rd power, right? Wouldn't that fix it? Okay, how about this one over here? Who can help me out with this one? Oren, can you help me out with this problem right here? It's 2,850,000. How do I rewrite that so I have it in scientific notation? So this right here should be 2 and 8,500 hundredths. Very good. Any question about that problem? Okay, here, last step. We need to match these. Match these. This scientific notation goes with which number? It says I got to move how many? I'm here in the second. Well, let's check. From the end of the second one, 1, 2, 3, 4, 5, 6. So does that work? Okay. There we go. Okay, what about the next one? Where's this one go? I'm here in the last one, and it's the same. It's very similar to the number above it, but how many zeros more? So we can go ahead and say that, right? And then the last one, that's the only one that's left. And we can verify that, right? Let's go ahead. 1, 2, 3, 4, and 5, and that does work. Okay, that is today's lesson. Are we good? What time is it? You guys like that lesson? Yeah. Hey, listen. Hey, for the most part, you guys did a pretty good job. That's very helpful to me when you guys are cooperating and you're doing what you're supposed to do, because I have a lot of work I need to do. I'm trying to get all your homework back to you before the test, okay? So that's a lot of grading I'm trying to get done. I would also like to get the test we took yesterday back to you before we take the test. The quiz we took yesterday back to you before we take the test. So that puts a lot on me to do. So this is helpful if I can get this done ahead of time.
Really?